சார்
எஸ் யஸ்
சார் இப்போ அதர் கண்ட்ரோலர்ஸ்லாம் இருக்குல்ல, ஃபார் எக்ஸாம்பிள் இன்ஃபினியான் இல்லை மைக்ரோடெக் அந்த மாதிரி ஏதாவது இருக்குன்னா, இப்போ அவங்களோட ஐடி வேற மாதிரி இருக்குமா கண்ட்ரோலரோட ப்ரோக்ராமிங்?
ஆமாம், அவங்களோட
ஓகே.
ஐடிஸ் ஏபிஐஸ் வேறு மாதிரி இருக்கும்.
ஸோ இப்போ
கான்செப்ட்
அதுக்காக
இதே தான். லைக் நீங்கள் எப்படி ஒரு இனிஷியலைசேஷன் பண்ணுறீங்க, அது எல்லாமே சேம், அந்த ப்ராசஸ் எல்லாமே சேம். ஆனால் ஏபிஐஸ் மட்டும் வேறு நேமில் இருக்கும், அவ்வளோதான்.
ஓகே. இப்போ அதுலயே நம்ம ட்ரை கோர் டுவல் கோர் சொல்றாங்களே சார், அது எப்படி
ஆமாம்,
சார் அது எப்படி பண்றது?
ஆக்சுவலாக இன்ஃபினியன் போர்டில் வந்து நமக்கு ட்ரைகோர் 5 கோர் இருக்குது, அதெல்லாம் இருக்குது, பென்டாகோர்லாம் இருக்குது. ஓகே, நிறைய டிரைவர்ஸ் இருக்கு. அதில் வந்து இப்போ நமக்கு ஒரு மெயின் டாட் சி இருக்கு இல்லையா?
ஆமாம்.
அந்த மாதிரி அங்கே கோர் 0, கோர் 1, கோர் 2 அப்படின்னு சொல்லிட்டு 3 கோர் இருக்கும்.
ஓகே
ஓகே, கோர் 0க்குள்ள ஒரு மெயின் டாட் சி, கோர் 1க்குள்ள ஒரு மெயின் டாட் சி, கோர் 2க்குள்ள ஒரு மெயின் டாட் சி. ஸோ உங்களால் 3 டிஃப்ரெண்ட் மெயின் டாட் சி ப்ரோக்ராம் ரன் பண்ண முடியும் அட் அ டைம்.
ஓகே, மூணுமே ஒரே லிங்க்ல இருக்குமா இல்ல வேற வேற ப்ராசஸ் பண்ணுமா சார்?
வேற வேற ப்ராசஸ் தான். ஒரே ப்ராசஸ் பண்றதுக்கு எதுக்கு நமக்கு 3 ஐடி?
இல்ல
ஐ மீன் 3 மெயின் டாட் சி.
ஏர் பேக்னா ஏர் பேக்
இப்போ ஒரு மெயின் டாட் சில இருந்து ஃபார் எக்ஸாம்பிள் டெம்பரேச்சர் சென்சார் வேல்யூ வாங்குறீங்க, ஒரு மெயின் டாட் சில இருந்து ஸ்பீட் சென்சார் வேல்யூ வாங்குறீங்க அப்படின்னா, இந்த மாதிரி 3 டிஃப்ரெண்ட் மெயின் ஃபங்க்ஷன்ல என்னென்ன பண்ணலாம் அப்படின்றது நீங்க தனியாக கொடுத்துக்கலாம். ஸோ 3மே பேரலா ரன் ஆகும்.
அதுதான் நம்ம ஆர்டாஸ்ல பண்றது.
ஆர்டாஸ்ல நம்ம சிங்கிள் கோர் வச்சு தான் பண்ணுவோம். பட் இதை அப்படியே ரெப்ளிகேட் பண்ணுறதுக்கு நமக்கு இன்னொரு விஷயம் இருக்குது, ஸ்கெடியூலர்னு சொல்லிட்டு ஒரு விஷயம் இருக்குது. அந்த ஸ்கெடியூலர் எப்படி இதை அந்த மாதிரி ரன் பண்ணுது அப்படின்றது தான் ஆர்டாஸ்.
ஓகே.
ஸோ ஒரு சிங்கிள் கோர்லேயே நம்மளால இந்த மாதிரி மல்டிபிள் கோர்ஸ் பண்ணுற வேலையை பண்ண முடியும். தட் இஸ் ஆர்டாஸ்.
ஓகே 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 சார்.
C++ என்னாச்சு, முடிச்சிட்டிங்களா?
முடிஞ்சு சார்.
ஓகே, டவுட்ஸ்?
நீங்க இது தரேன்னு சொல்லியிருந்தீங்க
ப்ராஜெக்ட்.
ஓகே,
டவுட்ஸ் எதுவும் இல்லையா?
எனக்கு இப்போ அந்த லிங்க் லிஸ்ட்ல வந்து நீங்க அதுல வந்து சிங்கிள் லிங்க் லிஸ்ட்டை பத்தி ஒரு இது இருக்கு, பேசிக்ஸா இருக்கு. ஸோ இப்போ அதுல டிராவல்ஸ் பண்ற மாதிரி சில டாபிக்ஸ் இருந்தா நல்லா இருக்கும்னு நினைச்சேன். இப்போ சென்டர்ல இருக்க ஒரு நோடை மட்டும் எடுத்துட்டு வேற ஒரு நோடு கனெக்ட் பண்றது, ஸோ லாஸ்ட் நோட ஃப்ரண்ட் நோட்ல மாத்துறது, டபுள் லிங்க் லிஸ்ட்ல யூஸ் பண்றது, ஸோ அந்த மாதிரி.
ஓகே, நான் எக்ஸாம்பிள்ஸ் ஏதாச்சும் இருந்துச்சுன்னா கொடுக்குறேன். என்னோட கிட்டப்ல இருக்கும்னு நினைக்கிறேன், நான் பார்த்து கொடுக்குறேன்.
ஓகே சார்.
ஓகே.
ஆனா சிலியும் நம்ம ரன் பண்ணலாம்ல சார் அது இதுல லிங்க் லிஸ்ட்?
டேட்டா ஸ்ட்ரக்சர் ரெண்டுத்துலயுமே இருக்கு.
ஓகே சார். ஆனா C++ல கொஞ்சம் சிம்பிளா இருக்கு அது.
ஆமா,
ரன் பண்றது.
ஆமா, நம்ம ஏன்னா C++ல நமக்கு டெம்ப்ளேட்ஸ் இருக்கும், டெம்ப்ளேட்ஸ் வச்சு நம்ம டேட்டா ஸ்ட்ரக்சர் ஈஸியாக ரன் பண்ணிடலாம். சில வந்து நமக்கு கியூ ஸ்டாக்லாம் வந்து அரே வச்சு கியூ மாதிரி ஒரு விஷயத்தை நம்ம பண்ணுவோம், ஆனா எக்ஸாக்ட் கியூ கிடையாது அது.
இதுல நம்ம ஸ்ட்ரக்சர் கிரியேட் பண்ணாமே வெறும் கிளாஸ்லயே அப்படியே ரன் பண்றோம்.
ஆமா, வெறும் கிளாஸ்லயே ரன் பண்ணலாம்.
ஓகே ஓகே.
C++ ஃபுல்லாவே ஆப்ஜெக்ட் பேஸ் தானே, ஸோ நம்ம கிளாஸஸ் அண்ட் ஆப்ஜெக்ட்ஸ் இருந்தாலே போதும்.
ஸோ அதே மாதிரி இப்போ நம்ம STM32ல C++ல கோடிங் பண்ணோம்னா எப்படி சார் அது? அதுக்கு ஏதாவது சேஞ்சஸ் பண்ணுங்களா?
ஆமா, நீங்க ஒரு நிமிஷம் நான் ஸ்க்ரீன் ஷேர் பண்றேன். இங்க ஃபைல் நியூல போயிட்டு
எனக்கு வர STM32 ஓப்பன் ஆகல சார், அது என்ன ஆச்சுன்னே தெரியல சார்.
ஆக்சுவலி எனக்கும் வரல, நான் இப்பதான் அப்டேட் பண்ணியிருக்கேன். இங்க ரைட் சைடில் அப்டேட் ஆயிட்டு இருக்கு, தெரியுதா? எனக்குமே இங்க எம்டி தான் காட்டுது.
அதான் எம்டினே காமிக்குது சார். அது கியூப் ஓபன் ஆகுது
சார். உங்களுக்கு ஓபன் ஆகுதா?
எனக்கு நான் சாயந்தரம் அப்டேட் பண்ணிட்டேன் சார்.
ஓ, அப்டேட் பண்ணதுக்கு அப்புறம் வருது கரெக்ட்டா?
வருது சார். அப்டேட் பண்ணதுக்கு அப்புறம்
ஓகே ஓகே, நான் இப்பதான் அப்டேட் கொடுத்துருக்கேன். லெட்ஸ் see 13% முடிஞ்சிருக்கு, பார்க்கலாம். இங்க இருக்கு இல்லையா டார்கெட் லாங்குவேஜ், அதை நீங்க C++ மாத்திக்கலாம்.
அவ்வளவுதான், வேற எதுவும் தேவையில்ல.
அவ்வளோதான், வேற எதுவுமே இல்லை.
ஓகே
ஸோ உங்களுக்கு கோட் ஜென்ரேட் ஆகுறது C++ கோட தான் ஜென்ரேட் ஆகும்.
ஓகே ஓகே.
ம்.
சார் அந்த நேம் வருது இல்லை சார், அது வரமாட்டேங்குது சார். STM32 ஐடி நேம்.
ஓகே, அது நான் என்ன பண்ணேன்னு சொல்கிறேன். இங்கே ஹெல்ப் போயிட்டு ஓகே ஒரு நிமிஷம் ரீஸ்டார்ட் பண்ணிட்டு வரேன். அப்டேட் ஆயிருக்கு.
ஓகே.
சொல்லுங்க விஸ்மல்.
அந்த நேற்று கேம்பஸ்ல டேட்டா வந்து ட்ரான்ஸ்ஃபர் ஆனதுக்கப்புறம் டெர்மினேட் பண்ணுறதுக்கு 120 ஓம் யூஸ் பண்ணுறாங்க.
ஆமாம் ஆமாம்.
அந்த 120 ஓம்ங்கிறது வேல்யூ எதை பேஸ் பண்ணி சார் கால்குலேட் பண்ணுங்க?
அது டிஃபால்ட் வேல்யூ, அது நம்ம மாற்ற முடியாது.
எது கால்குலேஷன் அந்த மாதிரி எதுவுமே கிடையாது.
இல்லை, கேன் ப்ரோட்டோகால் டிசைன் பண்ணும்போது யூ ஹேவ் டு கிவ் தட் ஒன், அவ்வளோதான்.
I2C சார்
I2Cல நீங்கள் என்ன ரெசிஸ்டர் வேணால் போட்டுக்கலாம். நம்ம அங்கே கிரவுண்டு இல்லை 5 வோல்ட் தானே கனெக்ட் பண்ண போகிறோம்.
ஆமாம் சார்.
அதுக்கு நீங்கள் 470 ஓம் ரெசிஸ்டர் இல்லை 360 ஓம் ரெசிஸ்டர் எது வேணால் போட்டுக்கலாம், ஏதோ ஒரு ரெசிஸ்டர். அது ஆக்சுவலி டெர்மினேஷன் கிடையாது. I2Cல இருக்கிறது வந்து யூஆர் கனெக்டிங் இட் டு கிரவுண்ட் ஆர் கனெக்டிங் இட் டு பவர் சப்ளை, அவ்வளோதான். அது டெர்மினேஷன் கிடையாது. பவர் சப்ளையோ இல்லை கிரவுண்டோ கொடுக்குறீங்க சர்க்யூட் க்ளோஸ் பண்ணுறதுக்காக. ஓகேவா? இதில் தான் உங்களுக்கு வந்து கேனில் தான் உங்களுக்கு டெர்மினேஷன் நடக்கும்.
ஓகே ஓகே.
ஒரு நிமிஷம். ஓகே, ஆக்சுவலி அப்டேட் பண்ணதுக்கப்புறமா இது மாறிடுது. ஓகேவா? ஸோ ஜஸ்ட் அப்டேட் திஸ். ஸோ உங்களுக்கு இஷ்யூ வந்து ஒரு ஜஸ்ட் கோ டு திஸ் ஹெல்ப். ஓகே, ஹெல்ப்பில் போயிட்டு STM கியூப் அப்டேட்ஸ்ன்னு இருக்கு இல்லையா, இங்கே போயிட்டு கனெக்ஷன் டு MyST.
ஓகே
ஓகே
ஓகே சார். அப்டேட்டும் அதுலயே வரும்ல சார்?
அப்டேட் வந்து நீங்கள் ஹெல்ப்பில் போயிட்டு இந்த இடத்துல செக் ஃபார் அப்டேட்ஸ்.
ஓகே சார்.
Okay. So my people, okay. Yeah. So just open this one more. Okay. So yesterday we discussed about this CAN protocol theory part, right? So we saw what is a CAN protocol and why this CAN protocol has been developed. First, what is the necessity for creating this CAN protocol and how this CAN protocol will work with the CSMACD protocol. Okay, what is meant by CSMACD and how this CAN physical device will be looks like we'll be having a microcontroller, CAN controller, and CAN transceiver. We saw what it is and how these nodes will be connected to the CAN high, CAN low. Okay, and both the sides of this CAN has to be terminated with 120 ohm resistor. This 120 ohm resistor as well as this is a constant value. Okay, because here we are using a twisted pair cable. Yesterday itself I told you, right? We are using a twisted pair cable for eliminating the magnetic interference. Okay, so for twisted pair cable, there will be some impedance. Okay, so 120 ohm is an nominal range for eliminating that impedance. Okay, you should not give more than 120 ohm or you should not give less than 120. 120 ohm is a constant value for eliminating the impedance in the twisted pair cable. Okay, so that's why we need to terminate at both the end of this twisted pair cable within 120 ohm resistor. And also we saw what is an dominant bit and what is a recessive bit. So if you have something like an CAN high and CAN low, okay, so any voltage difference between this CAN high, CAN low, if it is greater than 0.9, we call it as a dominant bit. And if it is less than 0.5, we call it as a recessive bit. Okay. So here, as per this CAN protocol, your 0 is a dominant bit and your 1 is a recessive bit. Okay, and we saw what is a frame format. Here we'll be having a two different frame formats. One is standard frame and the next one is the extended frame. Okay, and we saw what are the different fields available and what is the difference between standard frame and extended frame, how these values will be assigned, everything we saw. And then I think we saw the last as an error frame formatting. Okay, what are the different methods for finding out the error in the CAN protocol. Okay, so this theory part we finished yesterday. Today we are going to write a program for this CAN protocol. Right, so I'm just going to open this STM file, new STM32 project. Okay, so here I'm just going to select the board which I'm using for this module, F334 RET6. Okay, here I'm just selecting CAN hardware. Okay. Just a minute. Done. delete annotations. Okay. Yeah. So this is my board, STM32F334 board. Okay. So I'm just going to configure my CAN protocol here. Okay. So our first step is just go to the system core, make this RCC high speed clock as an bypass, and low speed clock, just enable this crystal ceramic oscillator. Okay, this is our first step for all the programs. And next we are going to use the CAN protocol, right? So I'm just going to click this connectivity over here, and this is the CAN. Okay, you can see over this CAN. Okay, just click activate it, right? And then you can see over here, we'll be having this PA12 and PA11 as an CAN TX and RX. It is not a CAN high, CAN low. Okay, as like I said yesterday, here we are having CAN TX and RX. Okay, so we need an external CAN transceiver module to communicate with other device. Okay, that transceiver module is going to convert this TX RX into CAN high, CAN low. Okay, and in some of the boards, we'll be having a direct CAN high, CAN low pin. So here you can directly connect it to different devices over there. Okay, that is possible. But as of now, we don't have this high low pin. We require an external transceiver to convert this TX RX into CAN high, CAN low. Okay. And here we'll be having a prescaler, time quanta. Okay, all these things, right? Just leave it as it is. We are not going to change anything. Okay. Just click Control S and then generate the code. Okay, so my code has been generated. You can see I have a CAN handler. Okay, and then I have this CAN initialization of the MXP. Okay, that's same thing what I have given, that has been given, right? Okay. So before writing this code, we just need to know a few things. Okay, it is not like an simple I2C SPI. There we have used only a single line of code for transferring the data, right? Here it is not in the case, because since it is a topology based communication or message based communication, we need to do some more things. Okay, I just tell you what are the steps we need to follow for writing the code. Okay, steps for CAN communication. Okay, step number 1. First, we need to configure the CAN filter. Okay, so there is something called as a CAN filter. I'll explain what this is. First step, we need to configure the CAN filter. Okay, and second step is we need to wake up and start the CAN peripheral. Okay, we need to usually start this CAN peripheral. If you have already started and if there is no transmission occur for some period of time, what will happen? Your CAN protocol will go to the sleep mode. Okay, so you need to wake up that CAN also. Okay, so we need to wake up and start this CAN peripheral. That is the second step. And third step, once this CAN has been started, we are going to prepare transmission or transmit header. Okay, that is this part. Where it is, yeah, this one. Okay, so we need to give this identifier. Okay, what is an identifier number? What is a DLC? All these things we need to use, and we need to define whether we are going to use a standard CAN or extended CAN. Okay, that is what called as an header. transmit data. Okay, so that is the third step. And fourth step, once you have prepared the transmission, we need to add the message to transmit buffer. Okay, so we need to add in CAN, we won't call it as a buffer. In only I2C and SP and UART, we'll be calling it as a buffer. Here, we call this as a mailbox. Okay, so we need to add the message to this mailbox. From this mailbox only, your CAN hardware will take that data and it will transmit the data. And whenever we are receiving the data, that received data will be available in the mailbox only. Okay, we need to fetch the data from the mailbox. So any data transmission or receiver will happen through this mailbox. So that is fourth step. And fifth step is once you are transmitted, start transmitting, we need to wait for the transmission to complete. Okay, so we need to wait for this transmission to be completed. This mailbox, whatever data available in the mailbox. Okay. And sixth step, okay, till this, your transmission part is done. Okay, if you're only going to transmit a data, then till this fifth step is done. Okay, sixth step, if you want to receive some message, okay, then you need to use the sixth step and seventh step. There are two different steps for receiving the data. Sixth step is we need to wait for a message in FIFO. Okay, that is your message will be available in the queue. Okay, we need to wait for the message to be stored in the FIFO. After that, we need to read this message. Okay, these two are optional. These are mandatory. You just need to follow these 5 steps for transmitting a data. Okay, and if you are just giving and loop back, that is you are giving this I pin and low pin, right? You are connecting this I pin to low pin for transferring a data. Then you need to follow the 6 step and 7 step. Okay, this is only for the loop back message. Okay, so we need to follow these steps. I'll explain each and every step one by one what it is. First, we need to configure the CAN filter. Okay, now what is mean by this filter, or what will happen without this filter means, okay, yesterday itself we saw we can able to connect multiple nodes in a single CAN high CAN low, right? Okay, so all these nodes are connected in a same CAN high CAN low pin. If node 1 is transferring any data to any different nodes, all these nodes can able to read this message. Okay, if node 1 is transferring a data to this particular node, any node can read this message. That is available for all the nodes. Okay, so first what will happen, let's assume your node 1 is transferring data to, I'll just write it over here. Node 1 is transferring a data to something like node 20. Okay, so each and everything is having a different address, right? Identifier, something like 0x, let's say this is 10 and this is something like in 0x45, any value. Okay, now what happens, first this node 1 will transfer a data. This node 2 will check whether this data is for this node 2. Okay, if the data is not for this node 2, it will just transfer it again. Node 3 will check again, node 4 will check, node 5, node 6, nodes. Okay, all the nodes will check this data, whether this data is for that particular node. Okay, until it reaches node number 20. Once it reaches node number 20, the data will be received in that particular node. It is actually a time taking process, right? Okay, because each and every node is actually looking this message for considering like it's thinking that message is for them. Okay, if it is not, then it will just return that message back. So it's not only taking a time, but it is overloading the CAN controller CPU. Okay, because there is a too much processes happening over here for transferring a single message. Okay, so in order to avoid that, we'll be using something called as a filter. Okay, so this one we'll be using a filter. So filter, what will happen? We are just going to give a particular address value. For example, I'm going to transfer to 0x20, right? I'm just giving 0x20 as a filter. Okay, that means only that particular address value will be received, or that particular address value will be transferred. Okay, so we are just filtering of all the messages. We are filtering only the 0x20. Okay, this filter we can actually able to give multiple values also. For example, if you want to receive a value from two or more different sensors. Okay, for example, I'll just give one thing. Okay, let's assume this is my cantaloupe pin, and I'm having some ECUs. Okay, let's say I'm having an 1, 2, 3, 4, 5, and 6 different ECUs. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 11 and 12. Okay, this canlo has been connected to each and every ECUs. For example, this is my airbag sensor. Okay, and this is my wheel speed sensor. Okay, and this is my automatic door lock sensor. Okay, and this one is, let's say, wiper control sensor. Okay, and this is my headlight. Sorry, not a sensor, ECU. Okay, headlight or parking light ECU. Okay, and this one we call, let's say, we are giving door lock sensor, right? Okay, let's say this is my power steering. Okay, so these are different different ECUs connected in the cantaloupe. Okay, let's assume like this. Now, this sensor may require or may need to transfer a data to other sensors. For example, this wheel speed sensor has to transfer a data to both airbag as well as this door lock, automatic door lock, because airbag has to sense what is the speed you are traveling, okay, in order to enable this airbag. And also this door lock sensor, once you cross something like a 30 kilometer, the door has to be automatically locked. Okay, for that it requires a wheel speed. And this wiper control is not required any of these things. And this is a parking light. It again needs an value from this wheel speed, that is your car is parked or it is not moving. We need to check that. Okay, and this is again a power steering. It may require this airbag value. Okay, and this wheel speed value and all these things. Now this wheel speed sensor is going to transfer 1, 2, 3, and 4 different ECUs. Okay, so now what will happen? This wheel speed sensor will have a filter of this, and this. Okay, And similarly, airbag is going to, let's say this power steering. Power steering is going to get a value from this airbag and wheel sensor. It is only having a filter of these two values, these two identifiers. Okay. So all other values will not transfer or will not disturb this particular ECU. Okay, that is what called as a filter. So filter is going to filter out or enabling only that particular address value, identifier value. It can be a multiple value also. For example, 0x45, okay, and 0x30. It can be multiple values. Only that particular value will be transferred or received in your CAN controller. Okay, that is what a filter. So we need to configure the filter to which address or to which ECU we are going to transfer the data. Okay, that is the first step. And second step, as you already said, we need to start and wake up your CAN peripheral. Okay, so if it is already started, you just need to wake up. If it is stopped, you need to start the CAN peripheral. Okay, after that, you need to prepare the transmit header. So this transmit header contains an multiple values like what is the data length. Okay, and so this transmit header, it contains the DLC value, what is the data length, and it contains the ID identifier. Okay, and then whether you're using a standard CAN or extended CAN. Okay, that you need to mention. Okay, and whether you are going to use an RTR. All these things has to be mentioned in this header for transmission of data. Okay, so we will just define the length of the data and the ID which you are going to transfer, all these things, right? Okay, sorry, just a minute. Okay. After we have configured everything, we just need to give some message. Okay, what message I'm going to transfer. Okay, that message has to be stored inside this mailbox. Let's assume you're going to transfer something like 1, 2, 3, 4, 5. Okay, so that message, this value has to be stored in the mailbox. From this mailbox only, the message will be transferred to the other CAN device. Okay, so that is, we are going to add this message to the mailbox. That is a fourth step. Once this message has been added, we are just going to transmit the data and we'll be waiting until this transmission is completed. Okay, so this is like some delay period, or we'll be waiting in that particular line for this transmission to be completed. Once this transmission completed, then again we will go to the step number 3 to transfer the next set of data. Okay, so that is what this is. And if you want to get this value back, that is called as a loop back, then we'll be using this one. Okay, this transmitted value that will be sent back to this RX again, and we'll be reading this RX message and we'll store it. Right. So that is what the steps for writing this CAN code. Okay, so we're just going to write the code for this particular steps. Clear? Any doubts? Anyone? If the steps are not clear, just let me know. I will explain it again, or we'll go for the code. Shall we go to the code?
Yes, sir.
Recording time. Okay, no issues. Yeah, so this is our CAN code. So we are just going to follow all the steps. Okay, so the first thing is we just need to create some particular headers and variables. Okay, so first one is this private variable. We are just going to use something called as an CAN tx header type def. Okay, so we just need to give header filter. Okay, for tx header, rx header, and one filter. We just need to create three different type def. Okay, so this type def is created by your STM itself. That is a generated code. This type def we need to give. You can give any name for this. I'm just giving something like an tx underscore header. Okay, and similarly can underscore rx header type def. Here I'm just going to give rx underscore header. Okay, after that we need an filter header. So I'm just giving can underscore filter type def. Okay, so here I'm just going to give filter, that is fi header. Okay, this name can be anything. I'm just giving this name. Okay, this is a user defined name. You can give anything for that. Right. So once it has been done, what we are going to do, we are just going to create some other variables. Okay. So first one, I'm just going to give this character tx, or just give t data. Okay, I'm just going to transfer some 5 different datas. 1, 2, 3, 4, 5. Okay, and then I'm just going to give an uint 32 underscore t of this tx mailbox. I'm just going to create one variable called as a mailbox. Okay, and this is for the data. I'm just going to send this data to this mailbox, and from this mailbox the data will be transferred. Okay, and if you want to receive the data back, then just give character space r data of 5, because I'm just going to transfer the 5 datas, right? So this will be 5. Okay, so these 3 variables I need. One is for transferring, one is for storing in the mailbox, and one is for receiving. Okay, so apart from this, headers. Okay, so this has been done, right? So next, what we are going to do, we are just going for this while of 1. Okay, so before this while of 1, our first step, okay, we need to configure this can filter that we will do in the function. Okay, so first we need to wake up and start this can peripheral, right? So what I'm going to do is, first I'm just going to wake up this one. Okay, so the wake up has to be given inside this user code to hal underscore can underscore wake up. Okay, so it is going to ask which can I need to wake up. So just give this hcan. That's it. Okay, so I need to wake up this, then I need to start this. So can underscore start. Again, it is asking which can. I'm just selecting this one. Okay, just a minute. I'm getting a call. Yeah, guys. Sorry. Okay, so I have given this wake up and I have given this start. Okay, so this step is done. This step is done. Okay, now I need to configure this scan filter, right? So for that, I'm just going to create one function which is called as scan filter. Okay, or filter configuration function, something like that. So I'm just going to call this one, like after can wake up, I'm just going to give this filter underscore config over here. Okay, let's say this is my user defined function. Okay, so I'm just going to give this user defined function what I need to do for this filter configuration and everything. Okay, so I'll just directly go to this user code 4 we'll be having here. Yeah, this one. Okay, here I'm just going to give this filter configuration, what filter I'm going to transfer and all these things. Okay, so let's say I'm just giving void filter config. Okay, it's this function. Okay, here I just need to do some more user defined or inbuilt APIs. First one is, okay, I need to use this header name. What is my header name? The header name I have given is an FI header, right? This can filter type. Okay, I need to use this one. So this is my handler. I'm going to create this handler dot. Okay, first one is filter activation. So I need to activate the filter, right? So for that, I'm just going to give can underscore filter underscore enable. So first I'm going to enable this filter activation. I'm going to activate the filter. Okay, that is the first thing. After this, again, I'm just going to give filter, fi dot header of, we just need to give this thing, okay, in order. Second one is filter bank, this one. Okay, so filter bank, I'm just going to give 0 value. Okay, there are multiple banks for filtering. For example, if you're using in different filters for each and every devices or every ECUs, then give this filter bank as 0, filter bank 1, filter bank 2, something like that. Okay, and the next one is same thing, fi underscore header dot, there is something called as FIFO assignment. Okay, so which FIFO I'm going to use here? I'm just going to use an can FIFO 0. So can underscore filter underscore FIFO 0. There are two different FIFOs, FIFO 0 and FIFO 1. I'm just selecting FIFO 0. Okay, this is nothing but the Q. Okay, Q1 and Q0. I'm just giving that value. And after this, here only I need to mention what is my filter value or which particular device I'm just going to filter. Okay, so for that, I'll be using this filter ID I and filter ID low. Okay, so filter ID I equal to, you just need to give the particular filter value. For example, in our case, we are given something like an, let's say, this is 45 and 10 I have given, right? Okay, so if you want to filter only that particular message or particular value, just give that particular value over there. Okay, I'm just giving something like in 0x45. I'm just going to do the left shift of 5 value. Okay, because here my 16-bit value will be assigned. Okay, for this entire 32-bit. So I just need to do this for the left shift for 5 times in order to make this present on the left side. Okay, and this is fi underscore header dot. This is for the I value, right? Similarly, low value, that is low 8-bit or 16-bit. I'm just going to give 0, 0. Okay, so in an entire 32-bit, the first 8-bit value is an 45 and the next 8-bit value is a 0, 0. Okay, so since our identifier value, you can actually able to give something more values, then we can actually able to give the 16-bit address over here. Right, so this is a filter configuration. So once this filter configuration is done, we just need to make this fi underscore header dot, there is something called as an filter mode. Okay, so click this filter mode, and I'm just going to make this filter mode as can filter mode as an ID list. Okay, whatever ID I have given, okay, that list of IDs has to be filtered. That is what an filter mode is. Here we have assigned only the value. We didn't say filter it. Okay, here only we are saying filter this value. Okay, and this filter value is nothing but it is an 16. This is 16. Okay, so totally it is an 82 bits. 32 bits, not 82. Okay, it's a 32 bit. Okay, so I'm just giving filter scale, this one, which is equal to can underscore filter scale underscore, either it's a 16 bit or a 32 bit. You just have to decide it. Okay, just click and 32 bit. Right. So once all these configuration parameters are done, we just need to call this hal underscore can underscore config filter. Okay, this can do the fi underscore header, whatever the value I have given for this particular under, config the filter for this. Okay, these are your filter configuration for this particular header value. I'm just telling this header value, and this can configure it by using this al. Okay, so this is what an filter configuration is. Clear? Here you just need to give which these are common for everything. Only these two values will be changing. It depends on which ECU address you are going to transfer. Okay, everything else is same. Is this clear? The filter configuration? Yes, is it clear?
Clear, sir.
Okay. Yes, so this is filter config. That is, after waking up your can, we will be just calling this function. Okay, this configuration will be done. So the first two steps are done. Step number one is configuring the filter, and step number two, we are just waking up the can and started the can. Okay, these two steps are done. Okay, and third step is we need to prepare the transmit header, and we just need to transmit the message. Okay, that is our next step. So we are just going to do that particular step right now. I'm just going to call another function, or create another function inside this while of one. I'm just going to give something like let's say can underscore tx. This is not an inbuilt function. Okay, this is a user defined function. You can give any name for this. For example, if you want to give, just give transmit, something like this. Okay, it's your wish. So I'm just calling a function can tx inside a while of one. That's it. I didn't call anything, only this particular function. So I just need to do what this function has to do. Yeah, user code begin for. User code begin for. This one. After this filter configuration, I'm just giving a void the same can tx. Okay. So what is the first step? First step is we just need to prepare the transmit header. Okay, that is my step number 3. So first we need to prepare the transmit header. So transmit header, what is an al function, sorry, al handler for header. So I have given this TX header, right? This is my transmission header header handler. So I'm just going to use this transmit header handler over here as TX dot header, sorry, TX dot header. Okay, TX, sorry, TX underscore header. Yeah. So TX underscore header dot, we just need to make this DLC standard ID, whether you are going to use a standard CAN or whether you are going to use an RTR. These 4 things we need to give. Okay. So first thing is some DLC, right? So I'm just going to give an DLC. DLC is nothing but the data length. How many datas we are going to transfer inside this CAN. That is what called as a DLC. Okay. Here, how many values I have? I have 5 different values, I think. Okay. 1, 2, 3, 4, 5. So I'm just going to transfer 5 different bytes. Okay. So I'm just giving the data length as 5 over here. You can give any number of datas we are going to transfer and all these things. Okay. And the next one is TX underscore header dot the standard ID. Okay, here I'm just going to use a standard ID, not an extended ID, standard ID. So standard ID equal to this value. Okay, the same filter value, whatever I have given that. Okay, that is my ID. Okay. After this, I'm just giving TX underscore header dot my ID identifier equal to whatever the CAN ID standard I have given, the same is for my identifier. Okay. After this, whether I'm going to use this as an RTR. Okay. So I'm just going to use CAN underscore RTR underscore data. Okay. I'm just going to transfer a data, not this RTR enable. I'm not going to use this RTR. I'm just going to use this data. Okay. So these 4 are my header, transmit header. Okay. How many datas, where I'm going to transfer, whether it is a standard CAN or extended CAN. Okay. And whether I'm going to use an RTR for this CAN transmission or not, that I'm going to define. Okay. Right. So this step is done. Again, step number 3. I have prepared the transmit header. Okay. Now I'm going to transmit this value to the mailbox. That is my 4th step. Correct. So what I'm going to do is I'm just going to give HAL underscore CAN underscore. There is something called as an add TX message. Okay. So it is asking 4 parameter, which CAN I need to transfer, what is the header value, and what is the data, and what is the mailbox name. Okay. So header name is nothing but it is a TX header. This is TX header I am going to transfer. Correct. So I'm just going to give this as TX header. Okay. So this TX header I'm going to transfer to the data, that is T data. This is what my data is, where it is. Yeah. This T data, I am going to transfer it to TX mailbox. Right. So this is what my step is. Okay. So this T data, I'm going to transfer to the TX mailbox. So I'm just going to give the ampersand TX mailbox. Okay. So I'm adding the message from this header, this data to the mailbox in this CAN. Okay. Once this message has been successfully added, it is going to return HAL OK. If it is successfully added. Okay. If not, it is going to return something else, a null value something. So I'm just going to check if this HAL CAN TX message, if it is not equal to HAL OK. Okay. That means if it is not equal to HAL OK, then I'm just going to call error handler. Okay. That means if this data couldn't able to store in this TX mailbox, okay, that is what not equal to HAL OK. Then I'm just going to call this handler. If it is not, that means if it is an AL, okay, then it will just come out of this loop, right? Okay, then what is my next step? My next step is I'm just going to wait for the transmission to be completed. Okay, so for that we having an AL underscore can underscore is TX message pending. Okay, AL can is TX message pending for which can and what is the mailbox name? Okay, that I need to define. So this is an ampersand h can. Okay, and this one is the same TX box I'm going to use over here as an TX mailbox. Okay, so if the ALCAN message is pending in the mailbox, I just need to wait it over here. Okay, I'm just going to wait it, right? So in order to wait it, what I will do is I'm just going to give this while with a semicolon. Okay, this thing we already saw what will happen if I give a semicolon to while loop. Okay, it will wait until this becomes false. Okay, so if it becomes false, it will just come out of that. If it is pending, it will be in that same loop. Okay, so that is what I have given. So these are the 5 different steps we need to use for transferring the data. Okay, so this 5 steps. So 5th step is also done. So once it comes out, what will happen? It will again go back to this while of 1. Okay, again this can TX will be called. Again this value will be set. Again it will transfer the value. Again it will wait. Again it will go back. Okay, it will be continuous process. Okay, so the 5 steps. First one is we need to configure the can filter and we need to wake up and start the can peripheral, then prepare the transmit header, add the message to mailbox and then transmit the message and wait for the message to be completed. Okay, so if I build this, I think I'll get some error. No errors. Okay, there will be warning for not defining this filters name. I'll just give it in the private function prototype, this one. And similarly, I have something called as in void tx underscore can, I think so. What is the name? Yeah, can tx. I'll build this one. I given 2 quite. Sorry. Okay, so that's it. So this is what the can data is. Okay, can program. So how the data will be transferred, how this data will be configured and all these things. Since we don't have any external hardware or this transceiver. Okay, so if you want to transfer this can, you just need to purchase this transceiver, that is can transceiver module, that is 2551, not this 2551. Yeah, there are 2 different can transceivers. Okay, it will be always confused. One is 2551. Okay, and the next one is this module 2515. Okay, so we'll be having, I'll just write it over here. There will be 2 transceivers. One is 25. So one is 2515. 2515 and the next one is 2551. Both will look something similar. Okay, but this is what we need. Okay, this 2515 is SPI to CAN converter. Okay, so we will be having this MOSI, MISO Okay, and then we'll be having the serial clock, all these pins and SS pins will be there. So that pin will be converted into this CAN high and CAN low. Okay, so this SPI data will be converted into CAN data. That is 2515. This 2551 is like CAN TX and CAN RX is going to be converted into CAN high and CAN low. This is what we need, this particular module. Okay, so I'll just show you the image of both the things. You will get an idea. This is like, yeah, this is your 2551. You can see over here 2551. I'll open the image. And this is 2515. So you can see over here, you are having an VCC ground, CAN TX, CAN RX. These two are inputs, and CAN high, CAN low. These two are your outputs. Okay, this module is what we need, 2551, this one. And this 2515 is like, you can see over there, there is a serial clock. Okay, this is your input, that is MOSI, MISO, and this is a chip select or a slave select. We have a ground and VCC. Okay, that data is converted into CAN high, CAN low over here. This output you can able to take in CAN high, CAN low, and this is your SPI input. Okay, so this module is SPI to CAN, and this module is your CAN transceiver, that is your CAN TXRX to CAN high, CAN low. Okay, so you need to get this one, 2551. It's the same, sorry. 2551. It looks something like in purple color. This one. Okay. So that is the hardware connection, and this is the program. Okay. Any doubts? Okay. Copy this code. Just let me know once you finish this program. Is it done? Yes, Yogesh, Yuvraj, Agustin, Ajmer.
சார் இந்த ஐடியே ஒர்க் ஆகல சார்.
அப்டேட் பண்ண ஒர்க் ஆகுது.
அந்த ஆப்ஷனே காட்ட மாட்டேன் சார். ஓப்பன் அந்த செக் ஃபார் அப்டேட்ஸ் கொடுத்தா ஐடியே
Okay.
க்ளோஸ் ஆயிடுது. திருப்பி ரீபூட் பண்ற மாதிரி இருக்கு. திருப்பி ஓப்பன் ஆகுது. செக் ஃபார் அப்டேட்ஸ் கொடுத்தா திருப்பி க்ளோஸ் ஆயிடுது.
ஓகே, இங்க ஹெல்ப் போயிட்டு அபவுட்ல என்ன வெர்ஷன் இருக்குன்னு செக் பண்ணுங்க. இந்த வெர்ஷன் நேம்
1.10.1 சார்.
10.1 ரொம்ப பழசு.
ஆமா. ஆனா நேத்து தான் சார் அப்டேட் கொடுத்தேன். அப்டேட் ஆயிடுச்சு. இப்போ நியூ வெர்ஷன் அப்டேட் கேக்குது, மறுபடியும் கேக்குது.
இங்க செக் ஃபார்
1.19
அப்டேட்ஸ் கொடுத்தா என்ன வருது?
1.19 வந்து நியூ அப்டேட்டா சார்?
ஆமா, 19 நியூ அப்டேட்.
ஓகே, இப்போ அகைன் சாஃப்ட்வேர் அப்டேட் போட்டிருக்கு. செக் பண்றேன் சார்.
ஓகே, அது
அந்த நேம் சார், நேம் பண்றது சார், அதுவுமே ஆகும் சார்.
அது ஒன்றும் பிரச்சனை இல்லை.
அது okay.
எனக்கும் நேம் காட்டல, ஆனால் லாகின்ல தான் இருக்கு.
ஓகே.
Others, Augustine, Ajman, Venkatesh, Yogesh.
சாஃப்ட்வேர் அப்டேட் ஆயிட்டு இருக்கு சார்.
ஓகே. Okay. No issues. And we have one more topic left. Okay. So that is not actually included in your module, but Ajmal said that in interviews they have asked this topic repeatedly. So I'll just teach this. Okay. So the next topic is bootloader. So bootloader is one of the, just type in boot. Okay. Bootloader. Okay, so bootloader is one of the basic concept, and I won't say basic in terms of the knowledge, okay, or in terms of what it is doing. Basic in the sense it is a first layer, okay, base layer of your microcontroller. That kind of basic, okay. It's not the level of learning basic, right? It is quite hard to write a code for you. Okay, so it is quite hard for you to write an bootloader for yourself. Okay, that is a different concept, different whole level, right? It is a separate module or separate course for creating this bootloader. Okay, your own custom bootloader. Okay, that is a different topic. First, we will see what is a bootloader and why it is needed in the microcontroller, what it is going to do, and all these things. Okay, that is more than enough for saying it in interview rather than writing your own custom bootloader. Okay, first of all, bootloader. What is mean by bootloader? Any idea for anyone?
Sir, voice is breaking.
Voice is breaking.
ஆமா சார், நடுவில் விட்டுருச்சு சார், கட் ஆயிட்டு திருப்பி இப்பதான் வருது.
Is it happen for everyone or only for yours? Is my voice got disconnected?
It's clear, sir.
Yes, sir.
என் சைட்ல ப்ராப்ளம் இருந்துச்சு.
ஆமா, இது இன்டர்நெட் இஷ்யூ இருக்கு. Okay, so what is bootloader? Any idea? Or have you heard about this word before? Yes, no, anything.
No, sir.
No.
boot loaderனா இந்த பவர் ஆன் பண்ணும்போது ரன் ஆகிற
Mm,
ஃபர்ஸ்ட் சாஃப்ட்வேர்.
mm,
ஸோ
mm.
that much only I can
Okay.
into that.
Okay. That much only is actually a bootloaders. Okay.
Okay.
Yeah. So bootloader. Okay. I'll tell you that simple thing. Whenever you turn on your PC or your laptop, there is one black color. Nowadays, it is not coming actually, but in previous laptops and previous PCs, if you just turn on, there will be a black and white screen will come, right? Okay, there will be some text like your
Press
hard disk
F1,
is
press F2.
press F1, F12 to boot and all these things. That is actually the bootloader. Okay, so bootloader is a small specialized program. Okay, a small specialized program or a software that is going to run immediately okay after you turn on power sub or when you press the reset button. Okay, this particular program will start running. Okay, that is the first program that will run. That is what called as a bootloader. Okay, in other words, we call this as a BIOS in your PC or laptop. Okay, so that is what called as an bootloader. So it is a small program. Whenever you turn on, this bootloader is going to run, and only this bootloader in your PC, what will happen? First, this BIOS program will run. This BIOS program is going to fetch your OS, whatever the OS, it may be a Linux or it may be an Windows. Okay, so it is just going to go to that particular location and turn on your operating system. Okay, that is the job of an BIOS. Okay, in your PC or a laptop, and it's the same thing for your bootloader. If you have any application written in your board, okay, even a small example, let's say your LED blinking. Okay, that is what an application code you are written, right? So when you upload the code in the board, what will happen? It will reset. Okay, once it is resetted, your bootloader will run, and it is going to start fetching this application code, and it will start running the code continuously. Once it is start running, it will just turn off. Okay, that is what in bootloaders. Okay, so this bootloader in embedded system, what will happen? It will perform two different operations. Okay, it will perform a two different operation. First one is it will just start, okay, and then it will jump directly to the application code. Okay, that is the first thing. Or what will happen in some cases, it will just go to the special mode to update new firmware. Okay, this BIOS in your PC, you can actually able to update the BIOS. Okay, so this BIOS or bootloader will perform two operations. One is it will start. After starting, it will just jump directly to the application. It will start executing the application. Okay, that is the first step. Or it will go to some special mode and it will just update your firmware. That is, even the bootloader software, you can able to update it, this software. Okay, you can able to update it. And this update can be done by using multiple ways. Okay, you can able to update it by using an UART. You can able to update it by using a CAN protocol. You can able to update it by using USB. Okay, SPI, I2C, any mode of communication protocol, or there is something called as an OTA, over the air. Okay, that is also possible with this firmware dish. Okay, so this is the job of a bootloader. Okay, Now comes the question, what happens if there is no bootloader present? Okay, if there is no bootloader present, first thing, if you want to update any firmware for your board, okay, even if I go over here and help, there is something called as an ST-Link upgrade. Okay, you can see over here. This is nothing but the firmware upgrade for your particular board. Your board will be having an ST-Link, right? You are just uploading this ST-Link. If you want to upload this ST-Link or whatever, any firmware upgrade, you just need to use a specific hardware to upgrade it. Okay, without bootloader. I'm saying this. You require something like a JTAG, you require something like any ISP tools or SW tools for using it without a bootloader. Okay, and second thing is, let's say we are talking about an automotive applications, right? All this scan, Ethernet, OTA, everything is an automotive applications. Okay, let's take an example of a Tesla car. Okay, so Tesla car is having a software when they are launching it, right? Okay, let's assume they are just selling some 100 different cars or some 500 cars to the customers initially. After a week, what happens? They found out there is some bug in the code that is making this car go some crazy. Okay, now they want to update a software for that bug clearance. Okay, what they will do, they will what they ask to do is they need to call all these 500 customers back to the service station, and there they just need to update this firmware, or they need to clear this error or bug, right? That is the way. Okay, but with this bootloader, what will happen? There is something called as an over the or on the air application. Okay, or on the air update. They can just send the package over the air, that is via this Wi-Fi or any network communication. This bootloader can able to perform this update inside the board. Okay, so that is the application of a bootloader. So a bootloader can able to make a firmware upgrade inside without changing or corrupting or damaging your hardware, something like that. Okay, that is what a job of a bootloader. So first job is it is going to make the application code to run. Second job is it is going to make any new firmware changes needed from the hardware level. I'm saying not an application code. Application code you can directly run it. Okay, but if you need any firmware upgrade change, then this bootloader has to done in some special applications. Okay, so there are multiple boards which is having a bootloader and which doesn't have a bootloader. Okay, first one is your Arduino ESP board that is having an bootloader. Okay, your Arduino board. Okay, your ESP 8266, ESP32. Okay, all these boards are having an bootloader. Okay, this is actually going to make the program run. Okay, whenever you press the reset button in the Arduino board, okay, or whenever you are writing any new code, okay, so this bootloader is the one that is going to make this one. Okay, also your PIC microcontroller. Okay, that is your 16F877A. Okay, or any PIC microcontroller which is having a bootloader. Okay, so that is why whenever you are uploading any code, you need to press the reset button in order to execute this code in the PIC microcontroller. Okay, so all these boards are having an bootloader inbuilt. Okay, then what about the board which we are currently using? That is your STM board. This STM32 boards is also having a bootloader. Okay, plus there is something called as ISP tools. Okay, it is having both the what to say bootloader as well as an ISP tool present inside your STM board. Also, there is there are some Infineon boards and there are some NXP boards. Okay, all these boards are having an ISP tool present inside these boards. Okay, now what this ISP tool will do is it is actually going to work as like the bootloader. Okay, in your board on the first class, I don't know whether you remember it. I'm just going to search this nuclei of 334 board. If I go to images, I told you, right, the stop off board is for the debugging purpose. This dotted line. Okay, and the bottom off is an programmer part. This is your ISP tool. Okay, it is not actually going to work based on the bootloader. Instead, this particular ST link, it is going to take care of all this debugging process, your code execution, your code conversion from the high level to the programming language, okay, machine level language. All these things can be done by using this ST link itself. Okay, and also we'll be having a bootloader. Okay, we can actually able to make some changes in the jumper pins, and we can able to disable this ISP tool and we can able to enable this bootloader. Okay, that is possible with all these ports. Okay, so that is what an bootloaders. Okay, so some boards is having only the bootloader and some board is having a bootloader plus ISP tools. Okay, now what is a job of the bootloader? Okay, or we call it as an the process flow. Okay, what is a process flow of this bootloader? Okay, that we are going to see. First, whenever you press a reset button or whenever you are turning on the microcontroller, okay, your microcontroller boots from the reset vector. There is something called as a reset vector address. Okay, usually the address starts with something like in 0x00, or in some boards it starts with 0x8000000. Okay, this is about your reset address, right? So when you press a reset button or when you press or when you turn on your microcontroller, your bootloader will directly go to this particular address or this particular address. Okay, after this it will start execution a specific flash region. Okay, so specific flash memory region will be executed. Execution starts. Okay, so the execution will be starting for a specific flash region. So what are the specific flash region is? It is going to enable the clock. It is going to enable the GPIO. It is going to enable some external hardware connections. If you have communication protocol, something like that, if you have, okay. So that communication protocols, all these things will be enabled by your bootloader. That is the second step. Okay, and the third step is after enabling these communication protocols and everything, it is going to check, is there any firmware upgrade? Okay, if there is any firmware upgrade, because your firmware upgrade will be usually done by using this communication protocol only. Either you'll be using an UART communication or you'll be using an CAN, okay, or you'll be using over the air communication. Okay, so once it is enabling this communication protocol, then it is checking if there is any firmware upgrade is pending. If it is not, or if there is any firmware upgrade pending, it is just going to flash that firmware based on what communication protocol it is going to do. or it will just jump to application. Okay, so this application is nothing but it is directly going to, there is something called as a stack pointer and program counter. Okay, so this is stack pointer and this is program counter. Okay, so it will just directly go to this particular address and it will start executing your application. Okay, so this is what the process flow of your bootloader. First, it will boot from that particular address and then it will execute the specific region of the flash memories like clock, GPIO and communication protocol. After that, it is checking if there is any firmware upgrade is pending. If there is any firmware upgrade, it will just execute it via that communication protocol, or else it will just directly go to this application. Okay. So if you want to see what is the location of this bootloader, just directly go to your data sheet. Okay, so we have already downloaded the data sheet, right? So you can just directly go to the data sheet and search memory regions. So just type memory. You can see boot modes. Okay, so there are two different boot modes available in the STM board, boot 0 and boot 1. Okay, so boot 0, it is going to boot like from the flash memory or from system memory or from the embedded SRAM. Okay, so there are three different boot options available over here. Okay, and your bootloader is located in the system memory. So if you want to execute from the bootloader, then you just need to enable this one. Okay, like it is, you can able to use this USART 1, USART 2 or an I2C for this boot mode. Okay, so that is available over here. So for each and every board, this boot device may be varying. Okay, so it depends on the number of pins you're going to configure and all these things. So this memory. Yeah. So this is your memory mapping. Okay. So you can see here the memory starting range or start value will be like 0000. Okay. So whenever you press a reset button, your boot configuration will be start running from the flash memory or a system memory or SRAM memory, depend on which boot configuration you are selected over there. We saw that boot 0, boot 1, right? Okay, based on that, whether I'm going to start booting from the flash memory or start booting from the system memory or start booting from the SRAM. Okay, that has to be decided in the level of 0000. So this actually varies from board to board. You just have to refer this data sheet for what is the base address it start executing. Okay, so you can see from this range to this range, a 64 kilobyte of memory that will be used for this one. Okay, so this is the bootloader, and there are multiple bootloaders. Okay, like where we are using based on that. I'll just tell you what are the different types of bootloaders available. Types. First one, your primary bootloader. Okay, your primary bootloader will usually present inside the ROM memory. Okay, it cannot be erased or it cannot be updated. This is a primary bootloader. you can't able to edit anything inside this one. Okay, that is in primary bootloader. And the next one is in secondary bootloader. This secondary bootloader can be upgraded. Okay, it can be a custom bootloader, or a user can actually able to write anything and they can able to update based on what they are going to enable and all these things. Okay, so that is an secondary bootloader. Okay, so it is present inside the flash memory. Okay, and you can actually able to write this bootloader as per your project. For example, in your project you only required and use art. There is no need to enable the I2C and all these things. So you can write a specific bootloader function or bootloader file for enabling only that particular communication, only that particular GPI opens. All these things you can able to done by using this bootloader. Okay, so it is present inside the flash memory. You can actually able to write your own project. Okay, that is possible. This is, you can't able to change anything. Okay, that is the primary. Okay, so this is the bootloader, a simple definition. Right, what is a bootloader, what it is going to do, and what are the things it can able to perform, and all these things. And so yeah, you just have to know until this, like what all these things can be done. Okay, and in some specific interviews they'll be asking you to write a custom bootloader. That is an entirely different process. Okay, so you just have to do a lot more things for writing in custom bootloader. You just need to have all the memory regions knowledge. Okay, and hardware level knowledge, like what are the memory regions you are going to enable, which particular specific peripherals, all these things you need just need to know for writing in custom bootloader. Okay, yeah. So with this,
Sir,
yes,
in which
yes.
language it bootloader programming is done?
Which one? This bootloader programming. You can write in a C language itself.
Is there any specific ID for each component, or you can write it
No,
on?
a bootloader can be run or can be write in a notepad itself.
Okay, notepad, and then how to you can debug or something, compilation not needed.
If you want to put that code in a specific board, there are some external hardwares available for that. Something like this JTAG something.
Just
Okay,
chilling.
you just
like
yeah, you just need to send this particular file to this microcontroller via that. Okay.
ஆக்சுவலா கஸ்டம் பூட் லோடர் பத்தி தான் சார் கேட்டாங்க இன்டர்வியூல.
அப்படியா?
அது நான் தான் உங்களை நான் தான் அதுதான் உங்களை
நீங்க
தான்
கேட்டீங்களா?
சொன்னாங்க.
ஆக்சுவலா அஜ்மல் கேட்டிருந்தான்னு நினைக்கிறேன். அஜ்மல் நீங்களே கேட்டீங்கல்ல?
ஆமாம் சார், லாஸ்ட் டைம் போஸ்ட்ல கேட்டிருந்தாங்க சார்.
ஓகே ஓகே ஓகே. கஸ்டம் bootloader இஸ் கம்ப்ளீட் அண்ட் டிஃப்ரெண்ட் ப்ராசஸ். அது எடுக்கிறதுக்கே நமக்கு ஒரு 5 days தேவைப்படும்.
ஆக்சுவலா ஜென்ரலா என்ன தெரியும் அதை மட்டும் சொல்லுங்க அப்படின்ட்டு சொன்னாங்க.
ஓகே
நான் வெறும் ஆன் பண்ணும்போது வரும் அப்படின்னு.
ஓகே ஓகே. சரி, you can just search in depth for this bootloader also.
ஓகே சார்.
Yeah, பட் கஸ்டம் bootloader எழுதுறது வந்து அதான் சொன்னேன் இல்லையா, இது அது மினிமம் ஒரு 10 hours தேவைப்படும்.
அது ஒரு அதுக்கப்புறம் சில பேர்கிட்ட கேட்டிருந்தேன், எங்க ஃபர்ம்வேர் இன்ஜினியர்ஸ்ட்டு கேட்டிருந்தேன். அவங்க அதான் சொன்னாங்க, அது ஒரு பெரிய டாபிக், அது ரொம்ப கஷ்டம், பெட்டர் நீங்க அதை அவாய்ட் பண்றீங்க அந்த கொஸ்டின் அப்படின்னா.
ஓகே, இஃப் யூ கோ ஃபார் அன் ஃபர்ம்வேர் டெவலப்பரா போறீங்க ஹார்ட்வேர்ல அப்படின்னா, தென் தே வில் பி ஆஸ்கிங் திஸ் கஸ்டம் bootloader. அப்போ தெரிஞ்சிருக்கும், அட்லீஸ்ட் பேசிக் நாலேஜஸ் தெரிஞ்சிருக்கும்.
STM32 மட்டும்னா எந்த மாதிரி ஜாப்?
STM32க்கு நமக்கு bootloader தேவையில்லை.
ஓகே, இது வந்து என்னன்னு சொல்லுவாங்க சார்? எம்பெடட் இன்ஜினியரிங் தான் சொல்லுவாங்க.
புரியல.
இல்ல இந்த பர்டிகுலர் போர்டுக்கு மட்டும் நம்ம ஒர்க் பண்றோம்ல. ஸோ இது வந்து கண்ட்ரோலர் ப்ரோக்ராமரா இல்ல எப்படி சொல்லுவாங்க? இது அப்ளிகேஷன் ப்ரோக்ராமரா எப்படி சொல்லுவாங்க இது?
இது வந்து அப்ளிகேஷன் இன்ஜினியர் வரும்.
அப்ளிகேஷன் இன்ஜினியர்.
ஆமா. ஏன்னா நம்ம வந்து அப்ளிகேஷன் டெவலப்பர் வரும். இங்க உங்ககிட்ட ஒரு போர்டு இருக்கும். இந்த போர்டுக்கு நீங்க ஒரு ஆப் மட்டும் டெவலப் பண்ண போறீங்க. அவ்வளவுதான். அது கோட் எழுத போறீங்க. ஓகே. ஸோ தட் இஸ் அன் அப்ளிகேஷன் இன்ஜினியர். ஓகே.
பட் நம்ம இப்போ பிசிபி போர்டுலாம் நம்ம இசியூக்கெல்லாம் நம்ம கோடிங் பண்றோம்ல சார். ஸோ அப்போ அதுவுமே அப்ளிகேஷன் லேயர்ல தான் வரும்.
ஆக்சுவலாக ரெண்டு டிஃப்ரென்ஸ் இருக்கு. ஒன்று, அந்த இசியூ என்ன பண்ண போகுது அப்படின்றது வந்து அப்ளிகேஷன். ஓகே ஓகேவா? ஸோ இசியூ ஆல்ரெடி டிசைன் பண்ணிட்டாங்க. அந்த இசியூ வச்சு நீங்கள் என்ன பண்ண போறீங்க அப்படின்றது அப்ளிகேஷன். ஓகேவா? அதுக்கு மேலே ஒரு ஆப் மட்டும் நீங்கள் டெவலப் பண்ண போறீங்க. அந்த இசியூ எப்படி ஒர்க் ஆக போகுது அப்படின்றது எழுதுறது தான் ஃபர்ம்வேர்.
ஓகே
ஓகே. ஸோ அதுக்கு தான் நமக்கு பூட் லோடர் தேவை.
ஓகே. நம்ம ஆனா ஃபர்ம்வேர் பண்றது இல்லைங்களா? நம்ம பண்ற
firmware
ப்ரோக்ராம்
பண்றது.
ஃபர்ம்வேர் பண்றோம் இல்லையா? அது அப்ளிகேஷனா?
இல்லை, டிவைஸ் டிரைவர் அப்படின்றது இப்போ I2C ஆல்ரெடி நம்ம கிட்ட இருக்கு அந்த போர்டில். கரெக்டா? அந்த I2Cயை நம்ம வச்சு என்ன டேட்டா ட்ரான்ஸ்ஃபர் பண்ண போறோன்றதை நம்ம எழுதுறோம். கரெக்டா? ஆனா அந்த I2C எப்படி ஒர்க் ஆகுது அப்படின்றதுக்கான ப்ரோக்ராம் எழுதுறது தான் ஃபர்ம்வேர். ஓகேவா?
அந்த புரோட்டோகாலுக்கு என்ன
அந்த புரோட்டோகாலுக்கு
அது
எப்படி ப்ரோக்ராம் எழுதணும் அப்படின்றது தான் இட்ஸ் அன் ஃபர்ம்வேர் லெவல்.
ஸோ ஆஃப்டர் இது யூசர் இன்டர்ஃபேஸ் பண்றோம்ல,
அது அப்ளிகேஷன் தான். யூசர் இன்டர்ஃபேஸ் பண்றது எல்லாமே அப்ளிகேஷன்.
இதுவும் அப்ளிகேஷன், அதுவும் அப்ளிகேஷன் தான்.
ஆமா.
ஓகே.
நீங்க இங்க அப்ளிகேஷன் டெவலப் பண்றது தான் யூசர் யூஸ் பண்ண போறாங்க. தட் இஸ் தி டாப் மோஸ்ட் லேயர். ஓகேவா? அதை தான் நம்ம யூசர் கிட்ட ப்ரெசென்டே பண்ண போறோம். ஸோ ஒன்ஸ் யூ டெவலப் அன் அப்ளிகேஷன், அதுதான் நம்ம யூசர் யூஸ் பண்ண போறாங்க. ஸோ தட் இஸ் ஆல்சோ கன்சிடர் திஸ் அப்ளிகேஷன் மாடல்.
ஓகே.
ஃபர்ம்வேர்ல எழுதுறது எல்லாமே பேர் மெட்டல் தானே சார்? இல்ல ரிஜிஸ்டர் லெவல் ப்ரோக்ராம் தான்?
ஆமா, எல்லாமே பேர் மெட்டல் தான்.
இந்த டிவைஸ் டிரைவர்ல எழுதுறது சார் நம்ம
டிவைஸ் டிரைவர் எழுதுறதுக்கு போத் பேர் மெட்டல் ஆஸ் வெல் அஸ் ஏபிஐஸ் ரெண்டுமே யூஸ் பண்ணிக்கலாம். ஓகே. பட் ஃபர்ம்வேர்ல நீங்க ஒரு ஹார்ட்வேர் லெவல் ப்ரோக்ராம் எழுத போறீங்கன்னா யூ ஜஸ்ட் ஹேவ் டு கோ ஃபார் திஸ் ரெஜிஸ்டர் லெவல் லாங்குவேஜ்.
ஓகே.
யா.
சார் இப்போ பிசிபி டிசைனுக்கும் வந்து STM32 கேட்குறாங்க சார் டிவைஸ் டிரைவர்ஸ்ல.
பிசிபி டிசைனா?
பிசிபி டிசைன்
STM
எப்படின்னா இப்போ காம்பினேஷன்ல சில இது வருது சார் ஜாப் டிஸ்கிரிப்ஷன். பிசிபி டிசைன் வித் கண்ட்ரோலர் ப்ரோக்ராமிங்.
ஓகே. டிசைன் அண்ட் போத் ப்ரோக்ராமிங் ரெண்டுமே தெரியும்னு கேட்டிருப்பாங்க. பிசிபி டிசைனுக்கு ஏதாச்சும் ஒரு போர்ட் நாலேஜ் இருந்தால் போதும்.
ஆக்சுவலா அந்த மாதிரியும் காம்பினேஷன்ல வருதா சார்? ஏன்னா ஒரு 2-3 ப்ரொஃபைல் பார்த்துருந்தேன். ஸோ அந்த மாதிரி காம்பினேஷன்ல கேட்டிருக்காங்க. ப்ரோக்ராமிங் கண்ட்ரோலர் ப்ரோக்ராமிங் பிளஸ் இது
நான் இது வரைக்கும் அந்த மாதிரி பிசிபி டிசைனுக்கு ஒரு ஏதாச்சும் ஒரு கண்ட்ரோலர் நாலேஜ் இருக்கணும்னு கேள்வி தான் பட்டிருக்கேன். ஸ்பெசிஃபிக்கா எஸ்டிஎம் வேணும் அப்படின்னு கேட்டு நான்
RTM சாஃப்ட்வேர் பிளஸ் இது கேக்குறாங்க சார். RTM சாஃப்ட்வேர் பிளஸ் டிவைஸ் டிரைவர்ஸ்.
டிவைஸ் டிரைவர்
அதான் STM தான்.
ஓகே. மேபி they are actually working with the STM board, custom STM board பண்ணுவாங்க. அதுக்காக மேபி அந்த நாலேஜ் தெரிஞ்சிருக்கணும்னு இருக்கலாம். ஆனால் ஏதாச்சும் ஒரு மைக்ரோ கண்ட்ரோலர் நாலேஜ் இருந்தால் போதும் ஃபார் திஸ் பிசிபி டிசைன்.
Okay.
Okay. Yeah, so this concludes your device driver. So we will have the class. Okay, we will start our RTOS from Monday, 14th. Okay, we'll start a new module from there. We are going to use the same board, this STM F4 series. Okay, M4 series architecture, same thing. So from Monday, we will start working on this RTOS. Okay, the same thing. Now we have used this device driver, right? So how to convert this specific board into a real-time board. Okay, and how to write a code for that we are going to use. And there will be using free RTOS software. Okay, it is an open source for RTOS. Okay, free RTOS. So we will download that. We will configure that free RTOS in our microcontroller. That is going to make your microcontroller as a real-time system. Okay, so that we will see from Monday. Okay. Yeah. And tomorrow you don't have any class. I'll send the project details to you by tomorrow. So for C++, bare metal pick, and device driver, all 3 projects. Okay. So there will be 4 project titles or 5 project titles in each and every module. You just have to select any one project from that. Okay. So select one project from the list of 5 or 4, depends on the questions level. Okay. Select one project and start working on that. Upload it in the GitHub link and share that GitHub link to me. That's it. Okay. So we'll see on Monday.
Sir, are
Yes,
you
sir.
available tomorrow, sir?
For what? That board
Sir, boats.
purchasing, right?
Yes.
Okay. Can we connect tomorrow afternoon? Around some
Yes,
4,
sir.
something like that.
Okay, sir. Fine.
Okay.
Okay.
Sir, your recorded videos in this.
இன்னும் வரலையா? நான் போடல, சாரி, நான் போட்டுறேன்.
Okay, sir. Same link, sir.
சேம் லிங்க், அந்த லிங்க்லயே எல்லா வீடியோஸும் இருக்கும்.
அது ஒரு வாட்டி வாட்ஸ்அப்ல மட்டும் ஒரு வாட்டி அனுப்பிடுங்க சார் லிங்க்.
சரி, திருப்பி வந்து அனுப்பிச்சு விட்றேன்.
ஓகே சார், தேங்க்யூ சார்.
ஆக்சுவலாக அந்த லிங்க் பின் பண்ணியிருக்கோம்னு நினைக்கிறேன், இல்லையா?
இல்ல, இது ஜாயின் பண்ற ஜூம் லிங்க் தான் பின் பண்ணிருக்கு.
சரி, ஓகே, நான் அப்போ இந்த லிங்க் பின் பண்ணி விட்டுறேன்.
ஓகே சார்.
Okay, thank you. We'll see you on Monday.
தேங்க்யூ சார்.
Thanks.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.